Alright, so in this video, we're going to talk about completing the square where our a term is greater than 1. So completing the square where our a term is greater than 1. So that means we have an actual a value. Just like we did the other completing the square, and if you haven't watched the other video of completing the square, I'd strongly recommend that you go back and you watch that first, because this can get a little bit more complicated. Frankly, mostly because you are dealing with fractions. And honestly, I'm not going to spend a whole lot of time on this because, frankly, to me, if your a value is not 1, if your a value is greater than 1, use the quadratic formula. Once you get to the point where you've learned the quadratic formula, use the quadratic formula. But it's a good idea to see what you're doing and understanding it and not be completely scared about it, okay? Because it's not that bad. It's just you're dealing with fractions. All right, so you want to rewrite your term where you have ax squared plus bx, and that's going to be equal to c. Well, okay, well, you're still going to be dividing that b term by 2, but the difference is that now you want to divide out that a term first. So let's look at my first example that I'm going to give you. Let's say I have the example of 4x squared plus 8x minus 5, and that's equal to 0. Well, first of all, I know that I have no GCF, so I can't divide any GCF out. So I'm going to divide everything by my a term. My a term is 4. All right? Well, all right, so 0 divided by 4 is 0. So the right expression is still going to be 0. So this is going to become x squared plus, all right, well, this isn't so bad. So 8 divided by 4 is going to give me 2x. And then, but this is, I can't do anything else with 5 fourths. So, and that's going to be equal to 0. All right, now, okay, so I'm going to move the 5 fourths over because I wanted to put it in the formula that we have up here. So this is going to become x squared plus 2x is equal to positive 5 fourths. Okay, well now I know it's in that same format, so ax squared plus bx is equal to c. I'm going to take my b term, so my b term is equal to 2. I'm going to divide that by 2 and square it. So that's going to give me x squared plus 2x plus, I'm going to add it to both sides, so that's going to be plus 1. All right, because 2 divided by 2 is 1. 1 squared is going to give me 1. Now, here's where the tricky part comes in because we have fractions. Now, if you remember, we can take our handy-dandy calculator, and you should have a copy of it in your phone, or your phone. So 4 divided by 4. All right, add 1 to it. All right, that's going to give me the decimal 2.25, but I want to leave it in fraction form. The reason that I want to leave it in fraction form is because if you notice, 9 is a perfect square and 4 is a perfect square. And look, we're trying to complete the square here. We're trying to find the perfect square trinomial. Well, we have a perfect square trinomial on the left. That's going to be x plus 1 squared is equal to 9 over 4. So now I'm going to take the square root of both sides. So that's going to give me x plus 1 is equal to plus or minus. Square root of 9 is 3. Square root of 4 is 2. Okay, so as you see, that's not too bad. So now we're going to subtract 1 from both sides. So that's going to give me x is equal to, well, now I'm going to take my calculator. So we said we have positive 3 halves, and then we're going to subtract 1 from it. So that's going to give me positive 1 half, or we have negative 3 halves, and then we're subtract 1, and that's going to give me fraction of negative 5 halves. All right, see you in the next video. I'm only going to do a couple more of these problems example like this because I really don't want the focus to be on these. The completing the square of the other ones I'm okay with, but these are really, personally for me, the best method would be if that a value is greater than 1. And your middle term, or your b term, is not a divisible